When dealing with gases and pressure, how can we prove that Boyle's, Charles, and Avogadro's laws create what is known as the ideal gas law, and are actually true and support kinetic molecular theory? The theory states that if a volume of gas is enclosed in some sort of container, the collisions of these tiny balls on the side of the container are responsible for something called pressure. Well, let's take it one law at a time and work our way up to the KMT. First, with Boyle's law. Boyle's law is about the compression and expansion of a gas at a constant temperature. This law is named after Robert Boyle, who in 1662 stated that the pressure of any given quantity of gas depends on this volume at a constant temperature. And in equation form, it is pressure times volume equals K, a constant. From this, we can form the hypothesis that as the volume of a closed container increases, the pressure will decrease. In this example, we are using a syringe with a topper on the open end to act as said closed container. The inflated balloon is inserted into the syringe, allowing us to view the effect of pressure within the closed container. When the plunger is pushed into the barrel of the syringe, we are decreasing the volume. As shown, the balloon starts to decrease in size and becomes harder to further push the plunger. This is because the gas molecules have yet less space to move around, causing the pressure to increase. This then supports our hypothesis: as volume decreases, pressure increases. This means that the relationship between pressure and volume are inversely proportional, meaning as one goes down, the other will go up.
The next law we are covering is Charles' law. Charles' law states that the volume that is occupied by a set amount of gas, which is proportional to its absolute temperature, which is a temperature measured from absolute zero in Kelvin, if the pressure in moles of the gas are constant throughout. So the hypothesis for this law would be that the temperature increases and volume decreases. For an example of this law is by using a hand boiler. Thermal heat from the hand placed on the base of the hand boiler heats the gas. Then the heated gas expands and pushes the fluid up. This then supports our hypothesis that when temperature increases, volume decreases, showing that the volume is directly proportional to temperature.
The final law is Avogadro's law. Avogadro's law states that volume divided by the number of moles in the container at a constant pressure and temperature give another constant. The equation for this law is volume over moles equals gas constant over temperature equals a constant if temperature and pressure are a constant. To prove Avogadro's law, you can put 14 Mentos into the balloon and put the balloon over the bottle of Diet Coke where the cap was. The carbon dioxide that was in the Diet Coke gets released when the cap is unscrewed. Before the Mentos were dropped in, the water molecules were trapping the carbon dioxide. When the Mentos are dropped, all the gas is released, which causes it to the liquid to thrust all the way up and out of the bottle. The only thing left in the balloon is release of carbon dioxide.